divide by h. Dividing by h, simply go to the denominator and put h either here or here, but ensuring that this expression in the denominator is in brackets, like that. At that point, you'll see that h cancels out. This one goes with that one. And therefore, we are left with 1 over this denominator here, which is this. Now that h has cancelled, you say the essence of us simplifying and doing it that way is to make sure that this h cancels, because we said that h shouldn't be equal to 0, because if it is 0, the expression will become meaningless. Now, for us to compute the limit, that is when we utilize h equals 0. So at this point, since the denominator, this h here that was dividing has cancelled out, that is now when we compute our limit. By replacing where we have h, just put there a 0. And when you put here 0, you remain with x, then plus 1. And then this one remains the way it is, which now gives us the expression above here. We get the expression up here. This one here, f dash of x is equal to 1 over root of x plus 1 plus root x plus 1, which when we add, they are similar. You can add them, and that means you have twice root x plus 1, and that is the final result. And therefore, we have differentiated from first principles, and our result is 1 over 2 root x plus 1. Just like that. As long as you have a square root, please, you need to rationalize at one point. So that is what we have. I hope they have listened well. Okay, do we have questions once again? Teacher, we can't see some part of the board. Okay. Mm. Okay, continue. Continue to one more. The next one, somebody said f of x is equal to 1 over root x. Okay, we are going to do that as the last example. And then we see how we can generalize this. Okay, the next one. Somebody said fx equals 1 over root x. That one there. The same one. We are going to begin by getting f of x plus h. F of x plus h, where we have x, we put there x plus h. Where we have x in this, we put x plus h. Therefore, this will be 1 out of root x plus h. Just like that. Once again, we are going to get f of x plus h minus f of x. First get that, so that you don't pile information in one place. First get the simplified form of this one. So that will be 1 over the square root of x plus h. This one here minus fx, which fx is 1 over root x. Now first simplify this. To simplify that one, we get the LCM here, which is the product of this times that one. The product of those two, that is root x plus h, then times root x. So that the numerator here we shall have root x minus root x plus h. Like that. Now, after it is to put h in the numerator, so that it can cancel out with the h that we shall have in our formula. Okay? Now, at this point, you see there is a difference in the numerator here. Therefore, you're going to also rationalize the numerator. The denominator, just keep it the way it is. Do not do anything on the denominator. Just only rationalize the numerator. So rationalizing the numerator will give us f of x plus h minus fx is equal to, rationalizing here, we know the conjugate of the numerator will be, let's first write it, root x minus root of x plus h. Put this in brackets, then into root of x plus root of x plus h. Kind of that. Then the denominator is first of all root of x plus h, like that, times root of x. Now put brackets here into, to cater for that conjugate, root of x plus root of x plus h. Like that. The mute microphone. Somebody should mute his microphone. Okay. Now, you see the numerator is again a difference of two squares. Just use the difference of two squares identity. We shall note somebody is saying, teacher, why can't we use the denominator? Our target is to generate h in the numerator, so there is no need of doing anything on the denominator. We just leave the denominator the way it is. So that is why we shall not use the denominator. We only need to look at the numerator here. It is the one that can easily generate for us that h. Now, Being a difference of two squares, we said just square the first one. When you square root x, you'll get x. Minus, since these are two variables, put brackets. When you square this, you'll get x plus h. Only that. So the whole of this has simplified to this one. That is, the whole numerator has simplified to this. The denominator, leave it the way it is. That is root x plus h times root x. Then this one is in brackets, root of x plus root of x plus h in brackets like that. Now at that point, you'll see that the numerator, when we open the brackets here, this x will cancel with this. This negative makes the numerator. What do we get in the numerator? In the comments?
Negative h.
Negative h. Therefore, I have a negative h in the numerator divided by the square root of x plus h times root x into root of x plus root of x plus h. Like that. Now that I've simplified the numerator, we now go to say our f dash of x from the formula of differentiating from first principles. F dash of x is given by the limit as h tends to 0 of f x plus h minus fx divided by h, of course provided that h is never equal to 0. Now you go and substitute. This will be now limit as h tends to 0. The whole of this numerator here is what we have in this step. That is fx plus h minus f of x. So this will be negative h divided by the square root of x plus h times the square root of x into root x plus root x plus h in brackets. This is only this part. I've copied only this. Now we need to divide this by h. Since you're dividing by h, simply put h there. You can put it here or you can put it at the beginning here. At that point, we can see that this h can go with this one. So that the numerator remains as
negative 1.
Negative 1. So I'll take a coffee break. I want you to complete that one. I want you to complete from here. I want you to proceed and compute the limit. After cancelling out h, somebody said we get negative 1. Well, now go ahead and compute the limit. To compute the limit, I said you simply replace where there is h after this one has cancelled out. Where you see h in the denominator here, put there a 0. And then you tell me the final result. A coffee break first. Okay, I believe we have written the first part. I now want us to continue. I already see answers. A negative 1 over 2x root x, that is very good. A negative 1 over 2x root x, very good. That is from Uwera and Munda. Munda, you're welcome, Sebo. Then, other members don't have any answers. Somebody is asking when the negative enters the brackets, the x cancels out because, okay, that was helping to explain to someone up. How did the negative h come about? Yes, maybe that time you were taking coffee. He explained there. You open here, this becomes negative x, this negative that becomes negative h. So the negative x and positive x cancels. You will be left with only negative h. Namutos, thank you for helping the friend. Okay. We continue. There are those who are stuck. Please don't be stuck like a goat in mud. You ask in case things are not working out. Want us to continue? Okay. Okay. Now we continue here. We said our new f dash of x becomes the limit as h tends to 0 of, we said this one goes with that, so you're left with only negative 1 in the numerator. Divide by root x plus h times root x. Then in brackets you have root x plus root of x plus h in brackets here. Like that. To compute this limit, we simply said put where there is h, put 0. If I put a 0 here, in this one, we remain with the numerator as negative 1. Putting 0 in this, there is h here. This will be root x alone. Then there is this root x to remains there. In brackets, I'll have root of x plus again root x because I've replaced this h as 0. So I'm left with only the square root of x. Then outside here, root x times root x, you see that gives us only x. Inside here, 2 root x plus root x will give us a 2 root of x. Like that. And therefore, you can finally have this as, some members have negative 1 over a 2x root of x. You've learned some algebra indices. We can also combine these and have something at once. Somebody give us the very final result from there. That is, what can we write here? I want us to have only a single x. What shall we have?
Negative 1 out of 2x.
Somebody says negative 1 out of 2x. Thank you for trying, but not exactly that one. I want you to use your indices and combine this into a single value of x. How do you get finally?
Yes, sir.
Yes. Sukuku, are you there? Okay. What do we get there? Use your algebra indices. Somebody saying negative 1 over 2x power 3 over 2. Yes. You know root 2x is x power half. Now you're multiplying x power 1 times x power half. You simply add the powers. Somebody has used this calculator, x power 1.5. We want them in fractional form, not in decimals. Please use fractions, not decimals. But thank you for your hard work. So we have negative 1 over 2x power 3 over 2. Another person will write it as negative 1 over 2 and then x power negative 3 over 2. Those are all correct results. Yes, all those who have written negative 1 over 2x power 3 over 2, thank you very much. Happiness Mageuzi and then Nicole Segawa, thank you very much. And that is what we had yesterday. Those who were not there, you can also consult in a later time where things are not working out, and we see how to help you. So is it wrong to write negative 1 over 2x? Of course, negative 1 over 2x is not similar to negative 1 over 2x root 2x. And you see you've written something different. We say there are 3 different versions here. You can write it as this one, finally, or you have it as this, it as that one. This is from our algebra. Indices. Okay. So that is what we had mainly yesterday. I want us to add a few more examples, then we look at something much better than that. Seguja is asking, can't we rationalize to remove the third? It will take us back to the same result of either this or this. So there is no need of you struggling with rationalizing. It will take you back to the same result. Actually, try it aside and you see how hard it is. If it is hard, then you come back and tell us why we don't need to write this. If it is simple, maybe we shall take your okay. So this is what we have, and I want us to add more examples here. Now there are those who probably went somewhere and you have some slight knowledge. And then, of course, I saw someone saying, aren't you using a wrong method? The method we are using is very correct as long as the question says we differentiate from first principles. We need to see you going through this way, utilizing this. If you don't use this, then what you're doing is not differentiating from first principles. You're doing something else. Okay, we can differentiate directly, but that is after knowing how these things come up, how they come about. And we shall look at that in a later time, not now. For now, we are looking at mainly first principles. When you're constructing a house, begin from the foundation. You don't begin from the roof. So this is the foundation of it. Where we begin from is here. The rest we shall meet in the middle. Okay. Now, in addition to what we have here today, we need to recall a few cases that we learned in trigonometry. In our trigonometry, we learned factor formula. We learned factor formula. And in our factor formula, that converts a sum or difference into product. That is what we shall mainly be using here. We said that if I have cosine of P plus cosine of Q, that will give us a 2 cos of P plus Q divided by 2, and then cos of P minus Q divided by 2. If I have a difference of 2 cosines, cos P minus cosine Q, we said we get a negative 2 sine. The first angle, you add P plus Q divided by 2. The last one, you subtract P minus Q and then divide by 2. We also looked at a sum of 2 sines, sine P plus sine Q. And we said that gives us a 2 sine cos. The first angle, add P plus Q, divide by 2, then cosine of P minus Q divided by 2. And lastly, we said if we have a difference of 2 sines, sine P minus sine Q, we get a 2 cos sine. The first angle, P plus Q divided by 2. The last angle, P minus Q over 2. Like that. Now, what we learned in trig is now going to be applied. For those who thought we were taking it just for fun, it is here. We are going to use it in several cases. And to begin with, we start from here so that we know how to differentiate trigonometric identities also. By the time we go to methods of differentiation, we know what we want. So if you don't recall, I want us to first note this one down. Note that factor formula. Then we can look at how to differentiate trigonometric identities from first principles. Okay, coffee break up. We now look at some examples. Look at some examples. Then we are going to differentiate. We shall work on those ones. I will do only, then the second one will be yours, the third one will be yours, and the fourth one, you tell us the results you get. To begin with, we have cos x. We want to differentiate cos x from first principles. You add here with respect to x. With respect to x, we are differentiating in terms of x. Our derivatives are in terms of x. Now, the first thing before we write the solution, you need to remember as well that when we are using trigonometric functions, the value x is an angle which is measured in radians. In calculus, everything is in terms of radians, not degrees. So what we have as x here, x is measured in radians. Now, if x is measured in radians, you'll also recall our approximations that we had, that sine of an angle, if the angle is x, sine of an angle, if that angle is very small, let's use a small angle, h. If h is a small angle measured in radians, then sine h is approximately equal to h. Mainly that one. Then we also had tan. If we use tan h, will also be approximately equal to h. This is true if and only if, say, provided our h is small, it is a small angle, and in radians. Is small and in radians, sine of that angle, that small angle, will be approximately equal to h. Tan of that small angle will also be approximately equal to h. But the main one shall be utilizing is this first one here. The other cases, we shall ignore them. Like that. Now, to begin by letting, we want to differentiate cos x with respect to x. Begin by letting a function fx be cos x. Like that. Then, just like what we did earlier, if I have fx, I'll go ahead and get f of x plus h. In this case, h is a small angle, x is also an angle, h is an angle, they are all measured in radians. And h being a small angle, we shall see the approximations we shall use. Where we have x, in this one said simply put x plus h. Then from there, we go and utilize our formula. Or if this is going to be hard for you to utilize the formula at once, you can first get the difference fx plus h minus fx, but this will not be bulky, and therefore I'll go ahead and utilize my formula of differentiating from first principles, which is f dash of x is given by the limit as h tends to 0 of f of x plus h minus fx, divide this by h. This is provided h is not 0. Our goal should be to find the value of h, cancelling out that h in the denominator. And once that is achieved, we shall be able to evaluate the limit. But before h in the denominator cancels out, you can't evaluate that limit. I want us to first copy this question is here, then you copy up to here, so that I have space. Copy the question, differentiate from first principles the following with respect to x. Those four will be enough for us today. I believe you've put factor formula somewhere, and you should be able to remind me what to write. Ensure that you've written that factor formula somewhere, or if you do recall, there is no need of writing it, but we shall need it. And lastly, you also need these approximations, especially sin h is approximately equal to h, provided our h is measured in radians and it is a small angle. H is a small angle and is measured in radians. I believe we are done with that, so I'm going to remove here. Okay, if you are done, I now proceed to my formula. We said f dash of x is equal to the limit as h tends to 0 of fx plus h minus fx divided by h. Now replace your fx plus h is this one. So I'll have f dash of x is equal to the limit as h tends to 0. We substitute. This one alone is cos x plus h minus fx, which is cos x, kind of that, divided by h. Everything is divided by h here. Now that you learn factor formula, I want you to apply factor formula and tell me what we get in the numerator here, cos x plus h minus cos x. Cos of x plus h minus cos x. What does it give us using our factor formula? Yes, somebody can unmute and tells us if you're sure. Who is that? You're listening.
We get negative for the numerator. We get
Yes.
negative 2 sine into x plus h plus x divided by 2.
Okay, I've had that. Negative 2 sine of
X plus h
x plus h
plus x
plus x
by 2.
divided by 2. Yes.
Then
Sine
into x plus h minus x
divided by 2. Like that. Thank you very much. Thank you very much. So we have that. -2 sine. The first angle you add this one plus this one divided by 2. The last angle you subtract this one first minus the last one divided by 2. Then we go ahead and simplify. First simplify and we see what we generate. So I have the limit as h tends to 0 of -2. Do not forget that negative. Sine. The first angle here, we see that we have x plus x, that will give us 2x, and then divided by 2. So you can write 2x plus h divided by 2. Here I have x minus x, that will cancel out. Then plus that h, so I will have sine of h over 2. Like that. Then everything is divided by h. Like that. Now at that point, that is when we bring in our approximations. Why? Because we are seeing a sine of h over 2. And we said h is a small angle that is measured in radians. Therefore, using our approximations, sine h over 2 will be approximately equal to, somebody will tell us in the comment section there, what does sine h over 2 become approximately equal to?
H.
Sine h over 2 becomes approximately equal to?
h
H out of 2, Asingwire, Raymond. Members don't get h, look clearly, there is sine h over 2. So you note that, those who have commented, h over 2, thank you very much. Somebody is saying 0. Xavier is not 0. Okay, it's not 0. Okay, now at that point you say, since, you can write this, since h is small, you make that comment, h is small and in radians. Just write that statement. Since h is small and in radians, the implication is that sine h over 2, this last one here alone, will be approximately equal to h out of 2. Sine h over 2 will be approximately equal to h over 2. Now that now brings us to f dash of x as limit as h tends to 0 of, copy this -2 sine, I have a 2x plus h, this is over 2 times, this one alone we said it has become h over 2. Then everything is divided by h. I want to see those with good eyes. You tell us what that simplifies to. And that will be our second last step before taking the limit. You tell us what that simplifies to. You can unmute and then you talk to us. And as you copy, meanwhile, you keep copying those who are. Do not wait until we stop for the coffee break. I know some of you are drinking water. That means it is a water break. Okay, someone animate and it tells us what remains. I see Jebed saying negative sine 2x over h. So negative sine 2x plus h. I believe you've forgotten something. Look closely. There's something you've forgotten. Okay. Perez Maguzzi, negative sine 2x plus h over 2. That is very good. Negative sine x, that is Wemba Serena. That will be the final result probably from Wemba. Why doesn't sine of 2x plus h over 2 become? Because there is x here. Therefore, this is not a small angle. X is not small. In that case, it is only h which is small. And that is why we mentioned here. Since h is small and in radians, therefore sine h over 2 will be the one which is approximately equal to h over 2, not this one here, because there is already x here. That x is a big angle, okay? It is only h that is a small approximation here, so it is a small angle, and that means it is only sine h over 2 that will be approximately equal to h over 2, not sine 2x plus h over 2. I hope I've mentioned that one. Shemukiza Isaac, that is very good. Unfortunately, there is a divided by 2 outside there. I think that one you didn't see it clearly. Now, the final result you can see here. Let's look at the blackboard. We have this 2. We'll go with this 2. Not this one inside here. This one is an angle, so it is not affected by any of the ones outside. This one will cancel with that, in case you can see clearly. Then this h also, I'm going with that one. I use some different ink. We said is this h that will go with that one. And then that ink is not visible. Try blue. Okay, can you see that one? With that one, and the one's cancelling out. Then I have a 2 with that 2. And therefore, the only result remaining is this one here, sine of 2x plus h over 2. And that will now take us to the second last step, where you now have f dash of x is equal to the limit. The limit as h tends to 0 of negative sine of 2x plus h. Divide this by 2. And at that point, I believe everybody can compute the limit. I want you to compute that limit and tell us the final result. Compute the limit and tell us the final result.